All right. Hello, everybody. This is Mr. Collins again. So we're going to be working through the Topic 8 Trigonometry Test Review. This is a hefty review, but I had to spread out the problems. You guys know how it is. Even though it's 22 pages, it's really not that much work. Again, on the front page, we have a breakdown of the exam, so you can see what every section's worth. It's a fairly balanced exam. It looks like we're going to have to find angles using trigonometry a little bit more than everything else. But overall, everything on the exam is really well covered. Okay, so again, this is going to be in parts. I still suggest that you work the review a couple problems per page, but in terms of being efficient with giving you an answer key, I am going to work this one section at a time, okay? So first section, Pythagorean theorem and its converse, but the first two pages focus just on the Pythagorean theorem and solving. So the thing we should note is that we always have a right triangle, and we always have two of the three sides of a right triangle. That is a perfect setup for using the Pythagorean theorem. Now, the Pythagorean theorem, if you recall, is a formula, or gives a formula: a squared plus b squared equals c squared. And so as long as we have a right triangle with two of the three sides, then a squared plus b squared equals c squared is going to apply. That itself is a Pythagorean theorem. Now, for this first problem, it's probably important to remember that we're talking about a and we're talking about b. We're talking about the two sides that are adjacent to or touching the right angle. If we're talking about c, that always has to be the hypotenuse, which is going to be directly across or opposite the right angle. What you use for A and B doesn't actually matter as long as it's not the hypotenuse. So in this particular case, we can substitute A to be 12 and B to be X. And then C in this case is going to be 13. To repeat, 12 and X can interchange places. It doesn't matter if you take 12 squared plus x squared, as long as 13 is not in there, because that's going to be the hypotenuse. Working this out, 12 squared is 144, plus x squared is equal to 169 for 13 squared. Now just solving for x, in other words, getting x by itself. Oops. Okay, we subtract 144 on both sides using the inverse operation. We're going to remove the 144, excuse me. So we'll be left with x squared is equal to 25. Okay, now to finish solving this, we will take the square root of both sides. Square root kills the square because they're inverse operations, and so x in this case is going to be 5. Now to check this work, although I'm not going to do it here, we'd want to put that 5 right back in for that x and confirm that the x value, 5 squared plus 12 squared, is equal to 169. Okay. So we're going to repeat this process several times, about 7 more times. So we have a right triangle. We have two of the three sides. So a squared and b squared have to be the two sides that are touching the right angle or adjacent to the right angle. And again, C has to be the side that's going to be across the right angle or opposite the right angle. And so for A and B, we can substitute 11.9 and then X. Okay, and that's going to be equal to C squared, which is 14.7. Okay, these are ones I can't do in my head, so we're definitely going to grab this calculator over here. Okay, so 11.9 squared is 141.61. X squared, we'll just say x squared. And then 14.7 squared is 216.09. Now we go about our solving routine. So we get x by itself by subtracting 141.61. And that gives us x squared to be the same as 216.09. Subtract 141.61. I have 74.45. To get rid of that square, we will now square root both sides. And that'll give me an approximate x value, because we do have to round here, of 8.628. Okay? Which seems legit because it's less than the hypotenuse, and really that's our biggest check. The hypotenuse has to be the largest side in that right triangle. All right. So here the trick they're trying to pull, although again it's not a great trick, is they're not giving us a picture of the triangle. Instead, they are giving us just the side lengths. But the Pythagorean theorem doesn't demand that you see the triangle, it's just that you know it's a right triangle. The fact that there's hypotenuse listed insists that this is a right triangle. And so we can immediately go into our solving steps. Okay, so leg 1 and leg 2 go in for A and B. And then x is going to be the thing we're going to solve for. The biggest mistake I see students make when using Pythagorean theorem is they assume they're always solving for the hypotenuse. In the first two examples, we're clearly not solving the hypotenuse. Here we clearly are. In terms of solving, 14 squared is 196. 20 squared should be 400. And that's going to be equal, in this case, to x squared. Okay, so let's do a little combining on this side. We have 596 is the same as x squared. And so you probably guessed at this point, we're going to square root. The inverse operation of a square is a square root. And so plus 196 square root. The x value, again, we're going to have to approximate. X value is going to be approximately 24.413. And since it's larger than the two leg values, that gives us confidence that we did solve that properly. Okay, so 21, other leg is x. That's going to be 35. Oops, where's that eraser? There you are. Okay, and the hypotenuse here is 35, so it should be 35 squared. All right, 21 times 21 is 441, plus x squared, of course. On this side, we'll have 35 squared, which is 1225. Okay, so now we're getting x by itself. So let's invert here. Okay, so addition to subtraction cancel, leaving us with an x squared. 1225 minus 441 gives us 784. Okay, then of course our last step, to kill the square, we use the inverse operation of square rooting. And that leaves us with an x value of approximately, oh, not approximately, 784. As 784 square root is going to be 28, so x is going to equal 28. Okay, now that should not exceed the hypotenuse, but the hypotenuse is 35, and so our value looks good to me. All right, so on page 2, and again, this is set up so you have multiple rounds of practice. We're going to just repeat what we did before. We still have right triangles. We still have 2 of the 3 sides of a right triangle, and so we can still use Pythagorean theorem. So a squared plus b squared is still equal to c squared. Our 2 legs still have to be touching the right angle. So we have 13 squared plus x squared. And our hypotenuse still has to be across from the right angle, opposite the right angle. And so that's going to be 15 for my c value. All right, so 13 squared should still be 169. Plus x squared. Okay, and then 15 squared should be 225, but I'm going to check anyway. There we go, 225. Okay, let's start getting x by itself. So 169 minus 169. And that will leave us with the x squared value being the same as 56. Okay, and of course we'll square root both sides. And so we can approximate our x value to be 7.48. Okay, lesson 15, we are good to go. All right. Okay. Now, hopefully, this is starting to become a routine. So even if you had to go back and redo last Wednesday's lesson, right before the topic started about the Pythagorean theorem and its converse, hopefully this is going to still be routine as we're practicing here. So 8 squared plus x squared. Okay, that's going to be equal to our hypotenuse squared. That's going to be 16. 8 squared is 64. X squared 256. Okay, so immediately we can start solving. Okay, so we have, let's see, x squared, the same as 256 minus 64, which gives us 192. Okay, and then we'll square root to kill the square. And so our x value is approximately 13.856. And we always do want to round to 3 decimals. Okay, so make sure you're observing that rounding standard. All right, 2 more in this set, and then we'll close this video. In the next one, we'll talk about the Pythagorean theorem converse, or at least we'll solve problems related to that. So leg 1, x squared. Leg 2, 83. Should be the same as our hypotenuse, so 132 squared. Okay, so x squared, these are going to be some large numbers. 83 squared, 6889 is equal to 132 squared, so 17424. All right, so getting x by itself. So we take 17,424, subtract 6,889, and we end up with 10,535. So to kill the square, we'll of course apply the square root. And we can approximate our x value to be 102.640. All right, one last one for this set. Okay, so 76.5 is going to be one of my values. X shall be the other. My hypotenuse value always must be C. And so I have 127.5 squared. So 76.5, 1 squared, will give us 5,052.25 plus our x squared. And that's going to be equal to, of course, 127.5 squared. Ooh, so 16,256.25. All right, so subtract off to get x by itself. So our x squared value, 5852.25, should be 10,404. Okay, so once we square root, our x squared, oh look at this, or my x. Who would have thought that? Is not an approximate. X is going to be equal to 102. Very cool. All right. So, having said all that, Pythagorean theorem, it's not new. It's something we've definitely reviewed and talked about a lot before, but you're going to have to know how to do it on demand. And so whether I give you a triangle with 2 of the 3 sides listed, or I just list out what the 2 legs and the hypotenuse are, you're expected to know how to solve using Pythagorean theorem. All right, so that's it for this video. I'll see you in part 2, where we'll talk about telling if a triangle is right, obtuse, or acute based on using the Pythagorean theorem. Thank you.